sige na.
Kasi. Okay na.
Salamat. Vera! Get out of here, get out of here, get out of here! Move, 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 move!
Ikaw ba ang nagbantay sa kanya?
Ayok ka! Kill! May gamot na sa sakit mo. Ito, gamot sa sakit mo. Para di ka na makagat ng mga tao.
Wala ko sakit.
Pero sabi nila, ano to may DNA technology na ginamit.
Damage or change in the genetic material of cells by environmental or internal factors sometimes results in cells that do not die and continue to multiply until a mass of cancer cells or a tumor develops.
Gene therapy is often brought up by patients as a potential approach, and many years ago the first gene therapy trials were done in brain tumor patients, and it was based on the incomplete but interesting data at that time that there were certain genes that were altered in brain tumors, and it dovetailed with technology that allowed us to introduce those genes back into patients. The complexity of the problem has been I think reinforced in recent years in that when now one has better tools to look at the genetics of these tumors, it is such a complicated genetic disease that there are thousands of genes, maybe more than that, that are involved in how these tumors grow. And the limitation that we have is the limitation of how many genes you can put into a vector, let's say, to get into the tumor. And initially we would do one gene. Maybe we'll be able to do two genes. But I don't think that that's going to be the answer because there are too many genes involved. Now, if we found some critical pathways that are controlled by one or two genes, which I think are unlikely, then maybe we could try again in that kind of approach. But the challenge is there are too many genes involved. So if we're going to use gene therapies, then we have to use them in conjunction with other therapies like radiation therapy, like chemotherapy, to take a population of those cells or tumors that still need a little extra treatment and try and introduce a gene or to turn off a gene at the same time we're using it with other strategies. The final challenge is how do you get these genes into all the tumor cells? That's very difficult because tumor cells are dispersed throughout the brain. You can't just give it easily by vein and hope that it just goes to those cells, and frequently we've had to inject these genes directly into the brain itself. So there's some limits about how that's going to be accomplished. There's some new ideas about how to overcome that challenge, but they're very complex. So I see gene therapy still in its infancy, but a lot of people who are very interested and very smart studying it, and I hope that we'll come to some better solutions soon.
Para yung sa genetic disorder mo maayos. Kung ano man, basta.
Hindi, kasi ganito yan.
The virus's envelope merges with the liver cell's cell membrane. This allows the virus's load of therapeutic DNA to penetrate the cell. It will find a path to the cell's nucleus. The virus proteins assure that the therapeutic gene is taken into the genetic material of the liver cell. This will enable the liver cell to function once again as a healthy cell.
Therapy is there's just one shot. For instance, there are certain eye diseases where you have what is called a protein replacement therapy, where you're actually putting in a protein into the eye, and you have to do this on a regular basis. It does not sound very comforting to me. So the idea that you would have one shot and be able to replace the function of this disease throughout your lifetime is actually maybe not appealing, but certainly more appealing than a regular routine of shots.
Hey,
Okay, dyan ka na. Shit. Ano yun? Limat, go-over na sila.
kaya makakasa tayo. Bitin pa ako. Nagugutom pa ako. Ako din.
Ah!